The universe is expanding faster than we can ever hope to chase it. Yet, a radical new vision for travel promises to collapse those impossible distances entirely. We are talking about interstellar highways, a network of cosmic shortcuts that could make crossing the galaxy as routine as a morning commute. By the end of this, you will understand the real science that could shatter the ultimate speed limit and open the stars to humanity. What mysterious force could warp the fabric of space itself to create a road between suns? And could such power be safely controlled? How close are we to turning this breathtaking concept into a tangible blueprint for our future? What would you be willing to discover on the other side of a doorway to another world? 4 light years is a distance so vast it defies human comprehension. Our fastest spacecraft, a tiny speck hurled from Earth, would require tens of thousands of years just to reach our closest stellar neighbor, a journey spanning longer than all of recorded human history. This is not a challenge of engineering or patience. It is a fundamental barrier written into the laws of physics themselves. The universe has set a speed limit, and that limit is the speed of light. Nothing with mass can ever reach it, let alone exceed it. This cosmic rule transforms our galaxy from a realm of potential neighbors into an archipelago of isolated islands, each separated by an ocean of space and time so immense that a simple hello could take generations to arrive. The dream of walking under an alien sun, of establishing a human presence beyond this single, fragile world, shatters against this simple, unforgiving reality. We are not just seeking a faster engine, we are searching for a key to a locked door, a way to bypass the rules entirely. This fundamental problem, this cosmic conundrum, is what forces us to contemplate the impossible, to look beyond rockets and fuel, and toward the very fabric of space and time for our salvation. The solution may lie not in breaking the cosmic speed limit, but in cleverly bending the road itself. Think of spacetime not as a rigid, unyielding stage, but as a dynamic, flexible fabric. A revolutionary idea born from Einstein's own equations, known as the Alcubierre warp drive, proposes doing exactly that. It envisions creating a stable bubble of spacetime around a spacecraft. This is the ingenious part. The fabric of space in front of the bubble is violently compressed, while the space behind it is dramatically expanded. The ship itself sits comfortably inside this warp bubble, nestled in a perfectly flat, undisturbed region of spacetime. It does not move through space faster than light. Instead, it is the space around the bubble that is moving, carrying the ship along like a surfer on a wave. This elegant sidestep of physics means the ship and its crew would avoid all the bizarre effects of near-light-speed travel, like severe time dilation where everyone back home ages decades while the crew experiences only days. But this cosmic shortcut demands a price, a form of matter that has never been proven to exist. To shape space-time in this way requires what physicists call exotic matter, a substance with negative energy density. Think of it as a kind of anti-gravity glue that pushes the fabric of spacetime outward to form the bubble. Without it, the entire structure collapses. So here we stand with a theoretical blueprint for an engine that can cross galaxies, but no known material in the universe to build it. This is the profound challenge and the breathtaking promise of the warp drive. It reveals that the path to the stars might be forged not by building better rockets, but by learning to become architects of reality itself. But what if you did not need to surf a wave of warped space? What if you could simply step through a door? This is the second grand vision for our interstellar highways, the concept of a wormhole. Picture the universe not as a vast, empty plane, but as a folded piece of paper. A wormhole is a tunnel that punches directly through the fold, connecting 2 points that would otherwise be impossibly far apart. These theoretical bridges, often called Einstein-Rosen bridges, are not tunnels through space, but shortcuts through the very fabric of spacetime itself. You would enter here and emerge thousands of light years away in an instant, all without ever breaking the speed limit locally. The journey would feel like walking through a corridor, a single step that spans the galaxy. Yet this incredible doorway comes with a monumental catch. A natural wormhole, if one even exists, would be incredibly unstable. The immense force of gravity would cause it to snap shut in a fraction of a second, crushing anything inside. To make it traversable, to prop the door open, we would need that same mysterious substance the warp drive requires: exotic matter. This theoretical material, with its negative energy, would act like a cosmic support beam, pushing against the gravity desperate to collapse the tunnel and holding the throat open for travel. Pioneering physicists like Kip Thorne have turned this science fiction staple into a serious field of study, calculating the precise physics needed to build and maintain such a structure. It is this profound understanding that transforms the wormhole from a mere curiosity into a potential foundation. If we could master them, wormholes could become the permanent on-ramps and off-ramps of a true interstellar highway system, fixed points in a dynamic cosmos that would truly bring the stars within our reach. Building a single warp bubble or stabilizing a cosmic tunnel would demand more power than our entire civilization has produced in its entire history. The energy required is not just immense, it is astronomical in the most literal sense. Early theoretical models suggested a warp drive might need an energy equivalent to the mass of Jupiter converted entirely into energy. Contemplate the Sun, that colossal engine of our solar system, releasing a staggering amount of energy every second. We are talking about harnessing a comparable output, but focused and controlled with unimaginable precision. This is not a challenge that can be solved with larger fuel tanks or more efficient solar panels. It forces us to confront a fundamental barrier in physics: the sheer difficulty of sourcing and controlling titanic forces without destroying the very apparatus we are trying to build. To bend the fabric of the cosmos, we must first learn to command the power of stars. Some scientists speculate that a truly advanced civilization would not merely inhabit a planet, but would construct vast, intricate structures around a star to capture every single photon of light it emits. These hypothetical megastructures, known as Dyson spheres, represent the kind of energy infrastructure that might be necessary to power an interstellar highway. Other, more exotic ideas involve tapping into the very fabric of empty space, attempting to draw power from the quantum fluctuations that constantly spark in and out of existence at the smallest scales. The leap required is so profound it redefines our concept of engineering itself. We must evolve from planetary engineers into stellar architects, learning to manipulate forces on a cosmic scale. How could we ever hope to contain such power, let alone focus it into a stable warp bubble or a traversable wormhole? The answers may lie in realms of physics we have only just begun to explore. This exotic matter, the hypothetical fuel for our cosmic ambitions, behaves in a way that seems to invert reality itself. Think of the gravity you experience every day, the force that pulls you down to the ground and holds the planets in their orbits. Exotic matter would do the opposite. It would push. It would possess a kind of negative energy density, creating a gravitational repulsion rather than an attraction. This bizarre property is not just a quirky detail, it is the absolute requirement for building our interstellar highways. For a warp drive, this exotic matter is what would violently compress the space in front of the ship and inflate the space behind it, creating the wave that carries the vessel forward. For a wormhole, it acts as the only possible support beam, pushing outward against the immense gravitational forces that are desperate to crush the tunnel shut in an instant. Without this cosmic scaffolding, both structures would collapse into nothingness faster than a thought. So where do we find such a substance? The answer is that we have only seen fleeting, microscopic hints of its behavior. In the strange world of quantum physics, the vacuum of empty space is not truly empty. It is a seething sea of virtual particles that pop in and out of existence. Under specific conditions, such as between two incredibly close metal plates in what is called the Casimir effect, this quantum activity can create a region with a negative energy density. It is a whisper of the repulsive gravity we need, a phantom echo of exotic matter, but it exists on a scale so small it is almost impossible to measure. The challenge before us is monumental. We must find a way to take this quantum whisper and amplify it into a stable, macroscopic force. We must learn to produce and contain a substance that, by its very nature, wants to push against the fabric of our universe. This is not a problem of engineering in the traditional sense. It is a deep dive into the most fundamental laws of physics, a quest to understand if reality itself can be persuaded to provide the building blocks for its own bypass. The entire dream of an interstellar highway rests on this single, profound mystery. Can we learn to harness a force that seems to defy the very universe we know? Mapping this cosmic highway presents a challenge far beyond any we have ever faced. The stars themselves are not fixed points on a celestial map, but are constantly drifting, each moving at its own unique speed around the center of our galaxy. A wormhole anchored near Earth today would, over centuries, find its other end drifting into the empty void between stars as its original destination star moves away. A stable network cannot rely on fixed points. It must be an adaptable, living system. This demands a form of navigation so advanced it would seem like magic to us now. Imagine a galactic positioning system that does not just track location, but monitors the subtle ripples and curves of spacetime itself in real time. It would need sensors scattered across the galaxy, feeding data to computers of unimaginable power, constantly recalculating the safe passage through every tunnel and warp corridor. A mistake in this calculation would be catastrophic, sending a ship not to a new world, but into the crushing gravity of a neutron star or the endless dark between galaxies. This is not merely about building the roads, it is about creating an intelligence that can watch them, understand them, and guide us as the universe itself shifts and changes around our fragile pathways. How could we ever build something that sees the entire galaxy as a single dynamic entity, and how would we trust our lives to its silent, perfect calculations? Deep within the apparent emptiness of a vacuum, a subtle but profound force emerges. Place two perfectly smooth, uncharged metal plates incredibly close together, separated by a gap smaller than the width of a virus. In this void, you would expect nothing to happen, yet the plates are inexplicably pulled toward each other. This is not magic, it is the Casimir effect, a real and measurable whisper from the quantum world. The space between those plates is not truly empty. It is a seething ocean of virtual particles that constantly flicker in and out of existence. These fleeting particles create a tiny pressure from the outside, but between the plates, only certain wavelengths can fit. This restriction means there is slightly less activity, less pressure between the plates than outside them. The result is a net force pushing the plates together, and crucially, the energy density in that gap is negative. For a fleeting moment in that microscopic space, the universe demonstrates the very repulsive gravity we are searching for. The scales here are almost laughably small. The force measured is weaker than a feather's touch. But its existence is everything. It proves that the exotic matter required by our grandest dreams is not a complete fantasy. It is a fundamental, if elusive, property of the universe itself. This tiny crack in the door of physics offers a tangible starting point. The monumental challenge, of course, is one of scale. How do we amplify a quantum whisper into a cosmic shout? Scientists are now exploring whether other materials or configurations could create a stronger version of this effect, or if different quantum phenomena could generate more substantial amounts of negative energy. The path forward is not about inventing a new substance from scratch, but about learning to coax this hidden property of reality out of the shadows and into a form we can control. Our interstellar highway may one day be built not from steel and fire, but from the quiet, persistent hum of the quantum vacuum, the very fabric of empty space becoming the foundation for our greatest journey. The same force that drives galaxies apart could one day power our voyages between them. Dark energy remains one of the most profound mysteries in all of science. We cannot see it or touch it, yet we observe its effect everywhere, a relentless pressure stretching the very fabric of the cosmos, pushing galaxies away from one another at an ever-increasing speed. This is not a subtle tug, it is the dominant force shaping the large-scale structure of our universe. While we grapple with its fundamental nature, its observable effect is undeniable. Space-time itself is being pulled taut. Now consider the mechanics of a warp drive, which requires the precise expansion of space behind a vessel. This is not a distant parallel, it is a direct connection. Understanding dark energy is not just about cosmology, it is about propulsion. If we can decipher the mechanism behind the universe's most powerful engine, the one that stretches space on a cosmic scale, could we learn to replicate that process in a controlled, localized field? Imagine being able to craft a pocket of expanding space, not by brute force, but by persuading the fabric of reality to do what it is already doing just for us. This would transform the challenge of building a warp drive from one of unimaginable energy requirements to one of profound finesse. Instead of fighting the universe's rules, we would be collaborating with its deepest tendencies. The ultimate interstellar highway may not be built by us from scratch, but rather, it might be grown from a seedling of cosmic expansion, a technology that taps into the same fundamental current that flows through the entire universe. The power to warp space carries consequences as immense as the distances it conquers. Envision the boundary of a warp bubble, a razor-thin region where the fabric of reality is bent to its limit. Theoretical models suggest this edge could act like a lens, focusing unimaginable amounts of energy. When the bubble collapses at its destination, this energy might be released in a violent burst of Hawking radiation, a shower of high-energy particles that could sterilize an entire planetary system. The danger is not only upon arrival. A ship traveling at warp does not simply push through the thin gas and dust between stars, it warps the space that contains them. Any stray hydrogen atom drifting into the path of the bubble would be swept up and accelerated to incredible energies. Upon deceleration, these accumulated particles could be unleashed in a forward-directed beam, a cosmic particle weapon with the destructive force of a supernova, all created unintentionally by the ship's mere passage. This transforms the act of travel into a profound responsibility. You would not simply be piloting a ship, you would be wielding a force capable of snuffing out stellar systems. To mitigate this, travel would need to be confined to pre-mapped and meticulously cleared corridors, true interstellar highways kept empty of debris to prevent catastrophic chain reactions. The challenge shifts from pure physics to one of cosmic-scale civil engineering and regulation, ensuring that our first steps into the galaxy do not leave a trail of destruction in our wake. The profound silence of the cosmos speaks volumes. We gaze at a galaxy filled with billions of stars, many older than our sun, and ask a simple, haunting question: where is everybody? This is the Fermi paradox, the stark contradiction between the high probability of alien life and our complete lack of evidence for it. The very concept of interstellar highways might hold the key to this cosmic riddle. Perhaps these immense structures are the hallmark of a maturity we have not yet reached. The energy and coordination required to build and maintain them are so staggering that they represent a technological plateau, a level of civilization we simply cannot yet perceive. A species must first learn to harmonize its own world, to harness the power of stars, before it can even contemplate paving roads between them. We may be like ants at the edge of a superhighway, oblivious to the traffic thundering by just beyond our perception. Another possibility is even more humbling. The highways are already there, but we are not on the map. The endpoints or the communication protocols for such a network could be deliberately concealed from emerging species. The builders might operate under a kind of cosmic prime directive, observing from a distance until a civilization proves itself ready, or perhaps until it proves it is not a threat. This leads to the most chilling explanation for the Great Silence. The act of activating a warp drive or stabilizing a wormhole is not a quiet event. It would send ripples through spacetime itself, a beacon announcing your presence across light years. For any advanced civilization, this could be an unimaginable risk. Broadcasting your location could attract the attention of something you do not want to meet. The decision to remain silent, to hide your roads and your travels, might be the ultimate survival strategy in a dark forest of a galaxy. So the emptiness we see is not necessarily emptiness at all. It could be a sign of a mature, cautious universe where the truly advanced do not shout into the void but listen. Our search for intelligence may be succeeding, for its most telling signature is the silence it deliberately maintains. The ship that rides a warp bubble must be built from a substance that does not yet exist. Containing a region of distorted spacetime is like trying to build a box out of tissue paper to hold a miniature black hole. The gravitational tides at the boundary of a warp field would be immense, stretching and compressing any ordinary material into subatomic dust. A wormhole's throat presents an even more terrifying environment, a gateway where the fundamental forces of the universe are twisted into a knot. The material lining this passage would need to resist being torn apart in two directions at once, holding its shape against pressures that could shred planets. This is not a problem of finding stronger steel or a more resilient alloy. We are talking about engineering a substance that can interact with spacetime itself, a metamaterial whose structure is designed at the quantum level to do one thing: to grip the fabric of reality and not let go. Think of it as a cosmic glue, but one that must also act as an insulator, a shield, and a conductor for the very forces that define our universe. The carbon nanotubes and graphene we herald as modern miracles are merely the first, clumsy syllables of a language we must master to speak to the cosmos. They are strong, but their strength is defined within our normal reality. We need a material whose strength is defined against the bending of reality itself. Without it, our beautiful theoretical blueprints are just intricate drawings on paper, destined to dissolve at the first touch of the immense forces they describe. The path to the stars is paved with equations, but it will be built atom by atom, in laboratories focused on a new kind of creation. We must learn to weave a fabric from the threads of spacetime, crafting a substance that can withstand the storm of our own ambition. What would it take to forge the anvil upon which the universe itself can be shaped? The architecture of an interstellar network would fundamentally reshape the very concept of value. Real estate would no longer be defined by a plot of land on Earth, but by a strategic position near a highway access point. A small, barren moon orbiting a star at a major junction could become the galactic equivalent of a bustling port city like Singapore or Rotterdam, its worth measured by the traffic flowing through its gateway. The most valuable commodities would shift dramatically. While we might trade in rare minerals or biological samples from alien worlds, the ultimate forms of wealth would be the energy and the technology required to build and maintain the highways themselves. A civilization that masters the production of exotic matter or the stabilization of wormholes would hold an economic power akin to controlling all the oil, all the currency, and all the shipping lanes of Earth combined. This new economy would not be planetary or even stellar, but truly galactic in scale. It would create entirely new forms of wealth and power structures we can scarcely conceive of today. The flow of resources would be unimaginable. A planet rich in the raw materials needed for warp coil construction could supply an entire sector, while a world with a unique biosphere might export novel medicines or cultural artifacts across thousands of light years. This interconnectedness would forge a single, sprawling economic entity, a civilization whose stability and growth are entirely dependent on the seamless operation of its cosmic roads. The collapse of a single major wormhole due to instability or a blockade of a key warp corridor could trigger an economic depression spanning hundreds of star systems. The very structure of this galaxy-spanning civilization, its politics, its culture, and its daily life, would be irrevocably shaped by the invisible architecture of its transportation system. What new professions would emerge in such a world? Would we see interstellar freight haulers, wormhole traffic controllers, or cosmic archaeologists studying the ruins of civilizations that built the first roads? A human ship gliding from the shimmering mouth of a wormhole would not be a silent arrival. It would be a declaration, an event that reshapes an entire world from the moment it happens. The ethical weight of that first emergence is almost beyond measure. We would be constructing a superhighway directly through what might be another civilization's backyard, a cosmic infrastructure project with consequences lasting for millennia. The fundamental question is one of rights. Do we possess the authority to build such an access point in a star system we did not evolve in, potentially disrupting a society that has developed for billions of years in peaceful isolation? This is not a simple exploration, it is an intervention on a stellar scale. The echoes of our own history are stark. Tales of first contact on Earth are often stories of disease, misunderstanding, and subjugation. To avoid repeating these tragedies on an interstellar stage, we would need protocols far more sophisticated than anything we have ever devised. A prime directive of non-interference would be the absolute baseline, a solemn vow to observe and learn without influencing a developing world. But what constitutes interference? The gravitational wake of a stable wormhole could subtly alter the orbits of planets over centuries. Our very presence in the system, even if hidden, might be detectable through emissions we cannot yet comprehend. The definition of harm itself would need to expand to include any disruption to a planet's natural biological or cultural evolution. Respect for alien ecosystems becomes a matter of galactic security. A single microbe carried on the hull of our ship, harmless to us, could become an apocalyptic plague on a world with no natural immunity. The act of building the highway itself could be interpreted not as an open hand, but as the ultimate act of imperialism, a permanent claim staked across the cosmos. An interstellar society would therefore require a robust legal and ethical framework, a complex body of galactic traffic law governing everything from right-of-way to emergency protocols. These would not be suggestions, they would be the foundational treaties preventing cosmic war. The design of our roads, the placement of their exits, and the rules for their use would become the most critical elements of interstellar diplomacy. The highways we build will not just carry our ships, they will carry our intentions, and the entire future of a multi-species galaxy may depend on the wisdom we embed in their very foundations. Even with our cosmic shortcuts, the ghost of Einstein's special relativity still haunts the journey. His theory reveals a universe where time is not a universal constant, but a personal experience that changes with your speed. As you accelerate toward the entrance of a wormhole or the activation zone for a warp corridor, your clock begins to tick just a fraction slower than the clocks on your home world. The same happens upon deceleration at your destination. While the main transit through the highway might be instantaneous, these bookends of the trip are not. They are moments of real motion where the laws of relativity fully apply. The cumulative effect over thousands of journeys could be significant. A pilot making regular runs between two stars might experience only a few months of subjective time, while back on Earth, decades have slipped away. This creates a profound social rift. You could leave on a simple trade mission and return to find your children older than you are, your culture subtly shifted, and your political leaders replaced by strangers. To function, an interstellar society would need to formalize this strange new reality. Highway time would become a recognized standard, a precise measurement of a traveler's personal duration, meticulously logged and contrasted with the steady, relentless tick of universal coordinate time. Synchronizing commerce, communication, and government across this temporal chaos would demand a level of computational and social coordination we can barely grasp. The flow of information itself would become asynchronous, with news from a distant hub arriving with a built-in delay not of distance but of lived experience. How would a civilization hold itself together when its citizens are literally living in different times? The answer lies in embracing the fluidity of time itself, treating it not as a river flowing in one direction, but as a complex web of interconnected moments, all managed by the silent, perfect pulse of the network itself. Perhaps the universe has already built the first roads for us. The cosmic construction project of an interstellar highway might not need to start from scratch, but could begin with a discovery, a search for infrastructure left over from the dawn of time. Some of the most compelling cosmological theories suggest that the fabric of spacetime is not smooth and uniform, but may be riddled with tiny tunnels, quantum wormholes forged in the unimaginable fire of the Big Bang. In that first explosive moment, as reality itself inflated from a single point to a vast cosmos, these microscopic bridges could have been stretched and expanded, woven into the very structure of the expanding universe. They would be ancient relics, cosmic shortcuts that have existed since the beginning of everything. The hunt for these natural wormholes is already underway, not with starships but with telescopes and mathematics. Astronomers search for their ghostly signatures, looking for the telltale warping of light from distant stars that cannot be explained by a single massive object like a black hole. A wormhole acting as a gravitational lens would create a unique and complex pattern, a double image or a strange, shimmering ring of light that betrays the presence of a tunnel rather than a simple mass. Other clues might be found in the chaotic regions around supermassive black holes, where the fabric of spacetime is already tied in knots, potentially hiding the entrances to these cosmic corridors. Finding a single, stable, traversable natural wormhole would instantly transform our place in the cosmos. It would be the discovery of the millennium, a ready-made on-ramp to a network we thought we would have to build ourselves. The monumental challenge of engineering exotic matter and containing titanic energies would shift overnight to the equally daunting but thrilling tasks of exploration and cartography. We would become cosmic surveyors, sending probes through the gateway to map its destination and stability, learning the rules of a road the universe built for us. This possibility suggests a cosmos far more interconnected than we ever dared to dream, a galaxy already stitched together by invisible threads, waiting only for us to learn how to see them. Our blueprints for these cosmic roads are currently written in chalk, easily erased by a single miscalculation. To move from theory to reality, we must first construct a perfect digital universe, a flawless mirror of spacetime where we can experiment without consequence. This demands a new kind of supercomputer, one whose processing power defies our current understanding. General relativity describes the grand curvature of the cosmos, while quantum mechanics governs the frantic dance of the very small. A warp bubble or a wormhole throat exists where these two titanic theories collide, a realm of immense gravitational stress operating at a microscopic scale. To simulate this, a computer must solve equations of almost infinite complexity, not over weeks or months, but in real time. It must model the subtle push of exotic matter against the crushing pull of a black hole's gravity, tracking every ripple and resonance across the fabric of its digital cosmos. These machines would become our ultimate laboratories. We could run 1,000,000 simulations in an afternoon, testing a subtle variation in the shape of a warp field or a new configuration for stabilizing a wormhole's throat. We could watch a virtual starship approach a simulated gateway, observing how its passage sends gravitational tremors through the surrounding star system. We could witness catastrophic failures, seeing a warp bubble collapse into a singularity or a wormhole snap shut, all within the safety of a server farm. Every dead end in the simulation saves us from an existential disaster in reality. The race to build these computational leviathans is therefore just as critical as the theoretical physics itself. They provide the only conceivable proving ground, a virtual workshop where the first interstellar highways will be designed, stress-tested, and perfected. Our path to the stars is being paved not in steel, but in lines of code, each one a silent question asked of the universe itself. That moment of arrival would be a sensory and psychological earthquake. Stepping from a familiar environment directly onto an alien world is a violation of every instinct our species has ever developed. Our minds are built for gradual journeys, for watching landscapes change over hours and days, allowing our consciousness to slowly acclimate to a new reality. An instantaneous transition offers no such grace. The very ground beneath your feet is wrong, the gravity a fraction too light or too heavy, the air carrying scents that have no name in any human language. The sky above is a permanent, jarring proof that you are no longer home, dominated by unfamiliar constellations or even multiple suns. This is not mere jet lag, it is a fundamental dislocation of the self, a condition we might call star sickness. It is the vertigo of knowing you are separated from everyone you have ever known, not by a long road, but by the continued operation of a machine, a fragile technological thread that could, in theory, be severed. Your entire existence in that new place depends on the stability of an equation, the integrity of an exotic matter reactor millions of miles away. This knowledge could breed a unique, low-grade existential dread, a background hum of anxiety that you are living on borrowed time in a universe that was not meant for you. Preparing for this goes far beyond physical training. Future interstellar travelers would need rigorous psychological conditioning, a form of cognitive fortification designed to build mental flexibility and resilience. They would practice mindfulness in radically altered sensory environments and undergo simulated transitions to desensitize their minds to the shock of the impossible becoming routine. The success of our interstellar ambitions will depend as much on the strength of our psyches as on the stability of our warp fields. We must engineer human consciousness to be as robust as the ships that carry it, ensuring that when we finally walk among the stars, we do not lose ourselves in the vast and silent dark. Control over the pathways between stars represents the ultimate strategic high ground. The civilization that masters the nodes of an interstellar highway would hold a power so immense it defies comparison. Imagine being able to move an entire fleet across thousands of light years in an instant, projecting force anywhere in the galaxy without the delays of conventional travel. A single choke point, a vital wormhole junction, could become the most valuable piece of real estate in known space. The entity controlling it would command the flow of trade, communication, and military movement for entire sectors. They would not need to conquer worlds with armies. They could simply close the gateway, imposing a blockade that would suffocate a star system's economy and isolate it from the rest of civilization. This is not just an extension of modern warfare into space. It is a fundamental reinvention of conflict itself, where battles are fought not over planets, but over the doors that lead to them. The defense of these critical infrastructures would become the primary military objective of any interstellar society. Fortifying a wormhole would be unlike any engineering challenge we have ever faced. You could not simply build a wall around it. Defenses would need to operate in the complex, twisted spacetime of the gateway itself, perhaps involving gravitational mines that disrupt incoming warp bubbles or sensor nets designed to detect the ripples of an unauthorized approach. The very technology that creates peace could also forge the most powerful weapons. A warp drive itself, as we have considered, could be turned into a planet-shattering bomb upon arrival. This sobering reality makes the peaceful development and governance of these technologies absolutely paramount. A single act of aggression using a controlled wormhole could ignite a conflict spanning hundreds of star systems, a war where the front lines are everywhere and nowhere at once. The decision to weaponize our cosmic roads or to collectively decide they must remain open to all could be the single most important choice our species ever makes. It is the difference between building a network that connects a galactic community and forging a chain that binds it. The void between stars is not truly empty. It is a fragile sea of hydrogen atoms, delicate dust grains, and invisible magnetic fields, a medium so thin it makes the best laboratory vacuum seem dense as lead. Yet this delicate equilibrium governs the birth of new stars and the flow of energy across the galaxy. Now consider the wake of a single warp transit. The violent compression and expansion of spacetime required for its passage would send powerful shockwaves rippling through this quiet medium. These ripples would not be gentle. They could ionize vast clouds of neutral hydrogen, stripping electrons from atoms and fundamentally changing the chemistry of a stellar nursery light years across. The subtle magnetic fields that thread the galaxy, acting as cosmic guide rails for charged particles, could be twisted and tangled by the passage of a warp bubble, disrupting processes we do not yet fully understand. A single ship might leave a scar that heals over millennia, but a busy interstellar highway with thousands of transits each year would create a constant drumbeat of disruption. The cumulative effect could reshape the ecology of entire spiral arms, perhaps even altering the rate at which new stars are born. We would be introducing a new, powerful force into a system that has evolved in near-perfect balance for billions of years. This forces a profound responsibility upon us to become the first cosmic environmentalists. Before we pave our roads, we must conduct long-term impact studies on a galactic scale, learning to predict how our technology vibrates through the fabric of the interstellar medium. The ultimate test of a mature civilization may not be its ability to build interstellar highways, but its wisdom to build them in harmony with the silent, living galaxy they traverse. Your home planet would become just one address in a sprawling galactic directory. The very idea of a homeland would stretch to encompass entire solar systems, forging identities built not on a single history, but on the shared experience of connection itself. We would become a multi-world species, and with that comes a fundamental rewriting of our social contracts. The old models of nations and borders, designed for a single, isolated world, would shatter under the weight of this new reality. How do you govern a civilization whose citizens are scattered across light years, living under different suns and in entirely different flows of time? The answer would likely be a layered system, a delicate balance of local planetary autonomy and an overarching galactic framework. Individual worlds would manage their own affairs, but they would all subscribe to a common set of principles governing the use of the highways, interstellar trade, and the profound ethical standards required for contact with other life. This framework would be less like a world government and more like a universal constitution, a bedrock of laws designed to prevent conflict on a cosmic scale. Culture itself would become a living, breathing tapestry woven from threads across the galaxy. A musical style born on a watery world could fuse with the rhythmic traditions of a species from a high-gravity planet, creating art forms we cannot even conceive of today. Culinary traditions would explode with ingredients from 1,000 different biospheres. Yet, this blending would not mean homogenization. Isolated colonies, by choice or circumstance, could develop into wildly unique societies, their cultures evolving in strange and beautiful directions away from the main currents of the network. We might even see the rise of entirely new kinds of communities. Imagine the void sailors, cultures that live their entire lives in transit along the highways, their massive world ships a permanent home between ports. They would develop their own traditions, their own languages, and their own unique perspective on the universe, seeing planets not as homes but as temporary stops. Their very existence would challenge our planet-bound notions of belonging and community. This vast interconnectedness would force us to redefine wealth, power, and purpose. Our current economic models, based on scarcity and competition, would be upended by access to the resources of thousands of worlds. The ultimate currency might shift from material goods to knowledge, to energy credits, or to something we have not yet imagined. The highways would not just transport cargo, they would carry ideas, philosophies, and dreams, forcing a constant and rapid evolution of what it means to be human. We would be forced to grow up as a species, to leave our tribal instincts behind and embrace our identity as vast as the roads we travel. The silent, perfect operation of an interstellar highway would demand a conductor of cosmic intelligence. No human mind, no team of experts could possibly manage the torrent of data and the split-second decisions required to keep this galactic network flowing. The gravitational pull of a passing star, the subtle drift of a wormhole's exit point, the emergence of a ship from a civilization with entirely different protocols, all of these variables would need to be processed and reconciled in real time across light years. This monumental task would fall to immensely powerful artificial intelligences, silent guardians woven into the very fabric of the system. These are not simple computer programs, they would be superintelligences, entities whose cognitive abilities dwarf our own. Their primary function would be safety. They would calculate the precise millisecond for a ship to enter a warp corridor, ensuring its bubble does not resonate destructively with the one ahead of it. They would monitor the structural integrity of wormholes, detecting microscopic fractures in spacetime and deploying corrective fields of exotic matter before a catastrophic collapse occurs. Think of them as the ultimate air traffic controllers, but instead of watching blips on a radar screen, they are perceiving and manipulating the fundamental geometry of the universe itself. Their negotiations would be as critical as their calculations. When two vessels from different species approach the same gateway, the AI must facilitate a handshake between incompatible computer systems and potentially untranslatable concepts of politeness and priority. It would need to be a master diplomat, a physicist, and a strategist all at once. This reveals a profound truth. The realization of our interstellar ambitions is inextricably linked to our success in creating a stable, benevolent superintelligence. We are not just building machines to help us travel, we are cultivating the minds that will ultimately govern the roads, the safety of every ship, the stability of every wormhole, and the peace of the galaxy could one day depend on the wisdom and empathy we manage to encode into lines of code. This places an incredible ethical weight on the field of artificial intelligence research today. Every breakthrough in machine learning and neural networks is not just a step toward a smarter phone, it is a foundational brick in a future interstellar command center. The ultimate question is not whether we can build such an intelligence, but whether we can build one we can trust with the keys to the galaxy. The stars have always defined the boundaries of our existence, their light a measure of our profound isolation. But an interstellar highway shatters that ancient relationship. For the first time, a finite human life would no longer be contained by the vastness between worlds. The philosophical weight of this is staggering. We have always understood distance as a fundamental, unchangeable reality, the great separator that keeps mysteries mysterious and dangers remote. To collapse that distance is to fundamentally alter the human condition. We would be stepping into a role once reserved for deities, making the entire cosmos knowable and touchable within a single lifetime. This power is not merely mechanical, it is existential. It forces us to ask what we owe to a universe we can now hold in our hands. Does turning the infinite into a network of manageable corridors strip the cosmos of its awe-inspiring grandeur, or does it deepen our reverence by allowing us to witness its countless wonders firsthand? The very act of building these roads demands that we grow up as a species. We can no longer see ourselves as insignificant inhabitants of a single, tiny world. We become participants, active shapers of a galactic story. Our purpose shifts from merely surviving on our planet to stewarding our place within an interconnected whole. The interstellar highway is therefore far more than an engineering project. It is the ultimate mirror, forcing us to stare into the void and decide what kind of civilization we wish to become when the entire universe is our home. A quiet revolution is unfolding in university laboratories and research institutes around the world, where the once dismissed equations of warp drives and wormholes are now being scrutinized under the harsh light of peer review. This is no longer the domain of speculative fiction, but a legitimate, if nascent, frontier of theoretical physics. The grand challenge before us is to build a bridge from these elegant theories to tangible, testable experiments. This bridge is being constructed piece by piece, starting with incredibly sensitive tabletop apparatuses designed to detect the faintest whisper of exotic matter effects. Scientists are not yet trying to compress a star system. They are attempting to measure a distortion in spacetime smaller than an atom. These minuscule experiments are the crucial first steps, the proof of concept that the universe does, in fact, allow for the manipulation of its own fabric on a human scale. Alongside this, supercomputers are running increasingly complex simulations, modeling warp metrics and wormhole stability in digital universes governed by the full, unforgiving laws of general relativity and quantum mechanics. Every simulation that runs to completion without collapsing into a digital singularity is a small victory, a signpost on the long road forward. This monumental endeavor cannot be the passion project of a few isolated geniuses. It demands a global commitment. International collaborations pooling intellectual and financial resources are essential to sustain the decades, perhaps centuries, of focused effort required. The journey to an interstellar highway is humanity's ultimate marathon, a relay race where one generation passes the torch of knowledge to the next. Our role now is not to witness the opening of the first gateway, but to lay its foundation with painstaking care, advancing the boundary of the possible one equation, one experiment, and one discovery at a time. Our journey across the theoretical landscape of interstellar highways reveals a path not of simple engineering, but of profound transformation. We have navigated the warped fabric of spacetime, contemplated cosmic doorways, and faced the monumental challenges of energy, navigation, and our own ethical maturity. This is not a distant fantasy, but a frontier of serious scientific inquiry, where the lines between physics and philosophy begin to blur. The obstacles are staggering, yet each one represents a beacon calling us to expand our understanding of the universe and our place within it. To master exotic matter is to learn the language of quantum reality. To build a stable wormhole is to become a sculptor of cosmic geometry. These are not merely technical problems, they are the very domains where a future civilization will earn its interstellar passport. As we stand on this threshold, the most important realization is that the greatest journeys always begin with a single, courageous question asked into the silence. The cosmic highways are not yet built, but their blueprints are being drafted in laboratories and minds around the world, awaiting their architects. Your curiosity is the first and most vital fuel for this endeavor. What role will you play in this grand adventure as a supporter, a dreamer, or perhaps a future builder? Share your thoughts in the comments below, subscribe for more journeys to the edge of science, and never stop looking up at the star-dusted sky, for it is a map of our shared destiny.